Lane, he wrote a graphing utility for the XML output that came out of the current cost. So I wrote a sketch on the Arduino that pretended to be a current cost, so I could just plug it into Dale Lane's application, and this is basically the power of the boiler in kilowatts versus time. So it was running at about 8 kilowatts, and then it comes on for a heating cycle, and as it heats up, it starts to wind down. This is a modern condensing boiler which turns the heat down as the water starts to heat up. It's got a modulating boiler, and that trace there was basically put together using a graphing application that's really intended for looking at the output of an electricity monitor. So the Arduino makes a great tool. You can get good data out of it. You can manipulate that data into different formats so that you can send it to different applications, and so it makes quite a powerful tool, even though the hardware is really very trivial. Finally, are there any questions on Gastel?
What are your gas meters outside?
There are ways around it. Yeah. You could conceivably take an optical fibre, which you can buy by the meter length. It's basically a bit of nylon or polymer cord, fishing line basically, polished at either end in a black sleeve, and you could have two of these optical fibres, one that's sitting next to the LED indoors and the other one is sitting next to the phototransistor indoors, and so you've made an optoflective sensor but with as long a light pipe that you want.
It'd be about 12 meters.
Yeah, it's doable. You might need to turn the wick up on the LED, but yeah, you will definitely get light out through there, and you'll definitely get light back down the pipe. So that way there'd be no electrics anywhere near your meter. So that'd be a good way of increasing that optical gap, and you could prove to the gas board that you were quite safe.
There's no reason why you couldn't run the wires with your type of connection that you were using.
Sure. Yeah.
That would work as well, because the very low currents down there. So
yeah, you can purchase fibre optic kits from people like Farnell and other people for about £15, and you get about 10 metres of fibre.
Is there any kind of flow rate thing you can put on the pipe as it comes into your house? Well, not you, some
not easily. The interesting.
You can really these fitting by a gas meter.
Yeah, well, how much are those sort of things?
Well, Transco, who legally own all the meters in the country, they will come out and fit a optically isolated pulse counter onto your meter, and they've got a fixed price for doing that, which is something like 550 quid, which tends to deter a bunch of people.
I'm deterred.
I looked at a device for water where there are no such constraints, because I can plumb that in.
Yeah.
And that was like 100 quid. So I thought, forget flow devices, they're too expensive.
You can get a low cost turbine-based flow sensor for about £40, which has a pulse output on it. And if you want to monitor your water consumption, that could be quite easily put in the rising main. Or you could have some optical technique to look at a pointer going around on a standard water meter. I got from eBay some very cheap water meters that had been used by Brita, the water softening people, and off some of their equipment that they install in pubs and restaurants, and I paid about £10 each for these water meters. And with a opto-reflective sensor like that, you could conceivably see the numbers go around.
Why was the difference between hot water flow meters and cold water flow meters?
In theory, there shouldn't be. It's just whether the plastics used within the flow meter are up to the 90 degrees C possible you might see in a hot water circuit.
Issues of pressure, isn't it? I mean, it's when you're putting it on the main input, you've got 10 bars there. So it has to be very well engineered not to die.
I share a half-inch main from the street with 4 other houses in my street. I don't have 10 bar.
No, I've definitely got 10 bar, I know, because
Yeah.
an accident caused by a badly done pipe joint. It was definitely 10 bars.
Okay, so you can monitor current and voltage quite easily, so you can look at your instantaneous power that your home is using. You can very easily look at temperature. You can monitor gas. You can tie gas consumption against the heating characteristics of your property. You can monitor the outside temperature, and you can say, my house leaks like a sieve, therefore my gas consumption is proportional to the difference between the outside temperature and the 19 degrees C that I liked indoors. And you can devise a constant of proportionality. So for any given temperature at 6 o'clock in the morning, based on past history, you can have an intelligent system which says, well, it's -3 out there this morning, therefore today this property is probably going to use 150 kilowatt hours of gas, costing about £4.50. So you can look at historical trends, and based on the temperature readings that you take throughout the night and early in the morning, you can predict how much you're going to use. If you're not going to be at home during that day, you can then say, well, I'll choose to terminate the heating in the property earlier, because I'm going out for the day, and then bring it on earlier. Predict when you're going to be home. So there are ways of saving energy within the home by understanding the heating and cooling requirements of your property, and this understanding comes through energy monitoring. Okay, the last thing I'd like to touch on is you've built yourself the world's best energy monitor. It's strapped to a laptop. You think, wouldn't it be good if I could have it in one room and just have a wireless link to another room? And so briefly I was going to touch on low power, short range wireless devices. These typically are available for £2 or £3. You buy yourself a transmitter and a receiver. The simplest way is to just send serial data at the data pin on the transmitter, and the simplest ones are amplitude encoded on-off keying, as they call it, and with a little bit of a protocol wrapper around your data packet, it's quite easy to send packets of wireless data from different sensors around the house back to some central point.
Have you done any range tests?
Yeah.
How far did you manage to get, like consistent data transmission?
I did some tests for a product that I was developing about 5 years ago. I've got a 65-metre long garden. My house is 20 metres front to back, and I could get from the far end of the garden through 4 solid brick walls to the front wall of the house with a 433 meg device.
And what sort of energy is it?
It's the transmit current on that was, I believe, about 4 milliamps at about 6 watts.
How are you driving it?
Just on off keyed. So it is possible to get domestic size ranges out of very simple on off keyed devices. I've got an example of one here. I've put together a little board to try and illustrate the simplicity of some of these circuits that I've talked about. This slide is this is a remote control socket that I bought from Lidl's, which has got a little superhet receiver on the other side and a rather useless decoder under that black blob there. So I put a PIC on the output of the receiver and wrote some code for the PIC so it decodes my my protocol packets that I was sending to it.
And what PIC is it?
It's 16F88. The protocol that I favour, it's an open source protocol called SNAP. It stands for Scalable Network something protocol, architecture protocol. It's about as easy as protocols come, and it's just a way of wrapping your data packet up with a simple header and a simple checksum, which gives you a better data integrity.
So basically you wrote your wireless protocol yourself?
I found some nice Italian chaps who'd already written it in PIC assembler, and I copied that. So, so this rather poor quality remote control socket became an internet controlled socket which could be turned on and off from any browser anywhere on the planet.
You can get a really nice socket as well from only about £4 or £5 from an outfit called Bye Bye Standby, which uses a decent protocol which you can easily. So you don't have to do that end of it if you don't want to. But of course, Ken will be cheating.
And sorry, what was that socket originally?
It was a remote control socket. It's you buy them from Lidl's. You get them in sets of about 4 for 20 quid, and you've got a 4-way remote control. But the problem with them was you'd have something switched on, and then some neighbour's doorbell would go off the street, also on 433. And the discrimination of this little processor on here was very poor, and so whatever was switched into this, the lights would go out or whatever. So
control the boiler off.
Yes. They're intended to fail safe, but a little bit too safe for my liking. So the illustration of this, I guess, is it's very simple to hack low-cost consumer electronics just with very simple hardware. I think that's the end of the slides. Yes. Are there any questions?
Yeah, on the van I've got a solar panel and a wind turbine.
Yeah.
And that's all 12 volt.
Yeah.
It's all disconnected. I was wondering what the options there for monitoring on that.
Okay. Right. The energy, so the current monitoring sketch that I've used is part of an open source energy monitor project by a chap called Tristan Lee. Tristan's based up in North Wales, and he has put together basically an arduino based energy monitor. He's got a strong interest in renewable energy, and he on his site describing the open energy monitor, he describes how you can use it for monitoring solar PV, wind turbine, and battery charging circuits. So it's openenergy.org, I think. Yeah. So a lot of the CT stuff that I'll be demonstrating later was based on Tristan's work. He would have been here tonight, but he can't get down from North Wales on a whim. Any other questions?
Can you talk a little bit more about the transmission, the wireless transmission receiver?
Right. Okay.
ICs you use?
Okay. The simplest wireless modules are amplitude modulated, AM, sometimes called on-off keyed, and basically the transmitter is a single RF transistor that produces carrier frequency at, in many cases, 433 megahertz, and you just turn that transistor on and off with a serial data stream. So they typically run at fairly low baud rates, up to about 4,800 baud. But it's as simple as you can get. You just send a serial bit stream out of a pin on the Arduino straight into the input pin on the transmitter module, and it produces a series of carrier pulses that vary in amplitude.
Right.
And then at the receiver end, the receiver converts that series of RF pulses back into a serial data stream, which you can just feed into another processor pin
And sorry, does that uses an RF receiver transistor?
You buy little modules from someone like RF Solutions,
right.
or if you Macklin,
Okay.
yeah,
pricey,
or Farnell, or RS Components.
Okay.
Another good stockist of them is Spark Fun Electronics in the States. But they've got to the point where they're only a few pounds each, and they're very simple to drive.
Right.
So if you want a basic RF link between one sensor and some sort of a receiving hub, it's an easy thing to do.
And how does that compare with things like Zigbee?
It's at least an order of magnitude lower in power consumption, but it's about 2 orders of magnitude lower in data rate. Zigbee has got a data rate of, I believe, about 250 kilobit per second, and these things typically run about 2.4K board, so there's about 2 orders of magnitude difference data rate. But Zigbee conversely uses 20 or 30 milliamps to receive and to transmit, and if you're working with a small battery operated system, you might not have that power available.
Yeah, they're for very different purposes, really.
Yeah.
Zigbee's for much more kind of infrastructural radio kind of deployments, whereas these things are more kind of ad hoc, data rate.
There are some kits for Arduino with Zigbee, and if you ever try to configure one, you won't want to do it again. Then it's literally impossible.
Yeah, Zigbee is quite over-complex.
Yeah.
There's lots of off-the-shelf equipment that does Zigbee, so if you're using off-the-shelf bits, you might want to use some Zigbee.
Yeah, Telegesis do.
If you're building it yourself, it's overkill, I reckon.
Yeah, don't get into it.
I've got a couple of those modules, by the way. Have you got some here? Because I've got some of those RF.
Yeah, sure, if you want to hand them around, people see them. I'm going to finish there, but what I will do after Ben has done his little presentation, we'll have a hands-on hardware demonstration, and I'm happy to answer any questions you may have. Apart from my slideshow presentation, most of the stuff is on my blog, and I can point you to where that is. And I'm quite happy to answer any sort of questions that you may have offline or at a future date.
One question. I first read about your project maybe, I don't know, 6 months ago, plus or minus a couple. And how has the uptake been since then? Have more people come on board, more data coming online?
Right. I've been somewhat busy for the last 6 months, so personally I haven't really done much to the project. I mentioned HomeCamp earlier. I'm trying to sort of get some of the London Hackspace and the HomeCamp people together, because I think there's a lot of synergy between those two groups. People who are part of the HomeCamp community, they are hacking gas meters, current cost, energy monitors, playing around with Arduinos, anything in the home that they think that it can hack, they can repurpose. That is basically their drive. And so HomeCamp has a conference, or rather an unconference, about once or twice a year. And we're also, this year, we're starting regular sort of once per month meetings, similar to this sort of forum we have here.
And you're based in Winchester, is that right?
No, the guys from IBM Hersley who put HomeCamp together, they're based down in Winchester, but we are a fairly metropolitan-based group. You know, the idea is to meet up once a month in a London pub or whatever, and just
not in this area actually.
Yeah, there's a lot of interest in this area, this end of town.
Ken, sorry, can I just say hi? I'm James Devine. I'm very late. I brought my Arduino-based power meter to show later, and I've got a couple of slides.
Fine.
If you, I'll join the back of the queue.
We'll let Ben do his 5-10 minutes, and then we'll set that up. And James's power meter has used one or two of the techniques that I've talked about this evening. He's put my theory into practice, and hopefully he'll be able to